Last time I left you, I was slightly confused, and I'll tell you exactly what I was slightly confused on. I'm actually completely okay, because multiplication of scalars is done in the normal way. The weird multiplication, the weird stuff for W is when you add together two elements of the linear space and multiply a scalar times an element of the linear space. Here, for AB, we're not doing either. We're just doing regular multiplication. So what I can do here is just say that this multiplication, that if I get here 4 to the 2 times 3, which I could, that just means I have an exponent here. In the weird vector space, I can put it on front and multiply it. So I'm actually completely good here. I just got a little confused. I thought that this maybe had to be the weird multiplication, but it wouldn't be because these two are thought of as scalars, because that's A and that's B, and those are scalars. So let's see how this looks like when someone competent does it. 3 to the E, that equals, with the weird multiplication, that means I can bring it up in the exponent. Oh, but this is now just high school stuff. I can put it there. And so that means that I can think of it as a single exponent, like so. So A times BC is equal to A times B times X. I said C there, I should have said X. And very, very similarly, -1 with a weird multiplication of 10 to the 7th is equal to 10 to the 7th to the -1 power, which equals 10 to the -7, which equals 10 to the -1 times 7, which equals -1 times 7, weird multiplication 10. So I've shown up for the weird vector space now. So I'm going to leave it at that, and I'm going to need some more space for 2 by 2 matrices, I think, so I'm going to stop. Oops. I'm in the wrong place. There we go. Alright, so I'm going to delete this. I'm going to eventually delete it. There we go. And now I need to do 2 by 2, 2 by 3. So again, I'll do 2 times 3 times 1, 2, 3, 4, 5, 6. And I'll do -pi times 2/3 times, I'll make it nice, 3,060. And I'll do 1 times 2 times 111,101. Okay, so again, just work this out. 3, 6, 9, 12, 15, 18 equals 6, 12, 18, 24, 30, 36. After I multiply by 2. Oh, but I can pull out a 6 out of here. 1, 2, 3, 4, 5, 6. If I want to, I could write the 6 as a 2 times 3, and I do want to. 1, 2, 3, 4, 5, 6. Alright, do something similarly here. -pi is on the outside. Multiply those two, I get 202,040 equals -2pi, 0, -2pi, 0, -4pi, 0. Oh, I can pull out -2pi over 3 times, and when I do that, I get 303,060, and I can rewrite this as -pi times 2/3 times 303,060. So that works. And finally, we'll do this one. That's going to be 1 times 222, 202, which equals 222, 202, which equals 2 times 111, 101, which equals 1 times 2 times 111, 101. So in each case, it's A times BX, A times BX, A times BX equals AB times X, AB times X, AB times X. Alright, I need to do P2. So that's going to be, again, like 2 and 3 times, how about x squared plus 1, pi and 6 times x squared plus x plus 1. How about make it 2? And then, how about, I don't know, 5 and 4, and then, these could be real numbers. Well, they are real numbers. 3x squared minus x minus 7. Alright, this is equal to 2 times 3x squared plus 3 equals 6x squared plus 6 equals 6 times x squared plus 1 equals 2 times 3 times x squared plus 1 equals pi times 6x squared plus 6x plus 12 equals 6 pi x squared plus 6 pi x plus 12 pi. Hey, I could factor out 6 pi out of here. 6 pi times x squared plus x plus 1. If I want to, I can rewrite this as pi times 6 times x squared plus x plus 1, and I do, because that shows me that a times bx is equal to ab times x. I'll work down for this one. 5 times 12x squared minus 4x minus 28 is equal to 60x squared minus 20x minus 140, which is equal to 20 times 3x squared. Oh, minus x. Minus 7. Good. Which is equal to 5 times 4 times 3x squared minus x minus 7. So I've done it for these two. Now I've just got one left. And that is this constant thing. So what I need is I need 2 times 3 times some continuous function. I'll call it sine x, where sine x is restricted. I don't know. 7/4 times negative 2/3 x squared, and 50 times a half times the function will be 2, just be a constant function. So that gives me, well, 3 times sine x gives me the function 3 sine x equals 6 sine x, multiply it through, equals 2 times 3 sine x. So what I have here is here's my function. Now here's my function. Now here's my function. Now here's my function. That's how I think of these functions. So here's my function. Now I can multiply two of these together to get negative 2/3 x squared. Now I have a new function that looks like all this. I can multiply these together to get negative 14/12 x squared. Here's my function. Oh, but I can factor this out to get negative 14/12 times this function, which equals 7/4 times negative 2/3 times this function. Alright, so there's a graph. This is equal to, right, here's the function, 50 times 1. Here's the new function, it's a constant function, equals 50. Here's the function, equals 25 times 2, scalar function, equals 50 times a half times 2. Done. We've done all the cases, and that's how you do number 26.